So I said earlier that when you're in free fall, all objects in free fall are weightless. It's like a spacecraft in orbit, or it is an elevator with a cut cable. It also means that if I jump off the table, that I'm weightless while I am in midair, so to speak. It means this tennis ball, while it is in free fall, it has no weight. Now it has weight. Now the weight is even higher because I'm accelerating it, and now it has no weight. The tennis ball is weightless, and I assume for now that the air drag plays no role. If I jump off the table, I will be weightless for about half a second. This is about 1 meter. If I jump from a tower which is 100 meters high, I will be weightless for 4.5 seconds, ignoring air drag. I prefer today the half a second. I'm going to jump off this table with this water in my hand. And I'm going to tell you how I can convince you that as I jump, that I will indeed be weightless. Here is the bottle. There's a gravitational force on the bottle. My hands are pushing up on this bottle. My hands are being a bathroom scale. I feel in my muscles the need to push up. In fact, I might even be able to estimate the weight, playing the role of a bathroom scale. It's a gallon of water. That's about 9 pounds. Now my own body, gravity is acting upon me, but I'm being pushed up right there. Suppose we jumped. There would be no pushing from me on the bottle anymore, no pushing there on me at the table. Only gravitation would act upon us, and we would be weightless. How can I show you that we are weightless? Well, if I don't have to use my muscles to push on this bottle upwards, I might as well lower my hands a little bit during this free fall. And you will see that the bottle will just stay above my hands without my having to push up. Therefore, being the bathroom scale, I no longer have to push on it. My muscles don't feel anything, and the bottle is therefore weightless. The bottle is weightless when we jump. I am weightless, and even this bagel is weightless. We're all weightless during half a second. There is no such thing in physics as a free lunch. You have to pay a price for this half a second of weightlessness. What happens when I hit the floor? I hit the floor with this velocity in this direction, which is about 5 meters per second. You can calculate that. But a little later, I've come to a stop. That means during the impact, there must be an acceleration upwards. Otherwise, my velocity in this direction could never become 0. Therefore, I will weigh more during this impact. There's an acceleration in this direction. The 5 meters per second goes to 0. If I make the assumption that it takes 2/10 of a second, that's a very rough guess, this impact time, then the average acceleration will be 5 meters per second divided by 0.2. That is 25 meters per second squared. That means the acceleration upwards is 2.5 g. That means I will weigh 3.5 times more. Remember, it is a plus g. So a is 2.5 g up, plus the g that we already have. That makes it 3.5 g. So instead of weighing 165 pounds, I weigh close to 600 pounds for 2/10 of a second. So we get 4 phases. Right now, I'm my normal weight if I stand on a bathroom scale. I jump for half a second, weightless. Hit the floor for about 2/10 of a second, maybe close to 600 pounds. And then after that, I will have my normal weight again. Now, you're going to have only half a second to see that this bottle, as I jump, is floating above my hands. I will pull my hands off. So you will see that I no longer have to push it. That means it's weightless. If you're ready, I'm ready. 3, 2, 1, 0. Did you see it floating above my hands? We were both weightless.